Hi folks, we're going to get started. So this talk is called Vulnerability Spidey-Sense. This is about sort of like intuition in pen testing. So we're going to be talking about things that you can see on a pen test that will give you an indication that something might or might not be vulnerable so that you can sort of prioritize targets during a pen test. So let's talk quickly about who we are before we get started.
So we're Trustwave Spiderlabs. We're the professional services division of Trustwave. We do traditional pen testing, forensics, research, and we're in application security.
So I'm Dan Crowley, aka Unicorn Furnace. I've been working in information security since 2004, and previously to that, I've been a hobbyist. I'm working in like Chris said, in the AppSec division. And I wanted to make it clear that the vicious lies from my detractors about me profiting on black market sales of unicorn horn, absolute lies. Don't believe it.
So I'm Chris Vinecombe. I'm a security analyst with Trustwave. I'm responsible for going through and doing some of the automated testing when we first start off a test, and also going through and grabbing kind of some of the low-hanging fruit. I may or may not own a grappling hook. I've got an upcoming court case, so if you really want to know about it, talk to me in November.
So the Spidey-Sense, what is it we're talking about here? So we're talking about prioritizing during a pen test. We're talking about intuition as to whether or not something is or isn't vulnerable. And we're going to talk about why this is useful and some ways that you can tell that something might be vulnerable just by looking at it, not even actually getting into the testing.
So during the course of a pen test, you're limited first by a schedule, right? We only have so much time to go through and test this stuff, whereas somebody that's truly kind of dedicated to trying to break in has as much time as they want. They can take, months or even years. Because of the time limitations, we're also going to be limited by coverage, right? So if we have a list of targets to look at, we're not going to be able to do an in-depth look at every one, and we're not going to be able to try every type of attack that looks like it may be useful. The last one is just an expectation of significant results. We have clients that expect us to come back with good stuff, and same with our bosses, right? They want to know that we're going to do a thorough pen test.
Sorry about that. So the question was, shouldn't the time that you are given match the number of targets that you're given? And in an ideal world, yes, but we do not live in that ideal world. I am frequently called. You get to that ideal world by selling companies on the idea that everything does need to be looked at, that everything does need to be secured. The problem is that I don't know that that is actually an ideal world. Bruce Schneier has a great quote where he talks about security being a trade-off. That I look around the room here and I don't see anybody wearing a bulletproof vest. You, sir, are not wearing full Kevlar armor, and you could be shot. But that's okay. You don't have to wear Kevlar armor because you're not on a SWAT team or something like that. So yeah, maybe you could wear full Kevlar armor, but probably you don't want to because it's fucking heavy stuff, Kevlar. I don't know if you've ever put on a Kevlar vest. That's sure, and that's reasonable. But there's definitely a difference though, because if you're talking about some bank versus like ilovepuppies.com, you're going to want to apply different levels of scrutiny to those different sites. So sometimes you have to test ilovepuppies.com, and you really want to see, can I break into ilovepuppies.com, but you only have like 6 hours and it's a particularly large site. So I don't have one. I'm sure there might be. I know Burp Suite has a tool to count the number of application URLs and the number of unique parameters, and by that you can give sort of an estimate. So yeah, Burp Suite is fantastic, and it has that nice feature. So you can sort of estimate it, but the truth is that frequently we and other pen test shops are called upon to do testing on large surface areas without enough time or resources to cover all of it, and so you do have to prioritize. So
we wanted to kind of get down to the nuts and bolts of it. Real quick, we have the broken windows theory. This is a sociological theory that says if you have a building that has a lot of broken windows or vandalism, it's more prone to more broken windows and more vandalism. It's basically because if you walk by a building, it's got all the windows are bashed in. You know nobody's maintaining it, probably not monitoring it too carefully, so you probably have a better chance to get away with it. You can kind of apply the same concept to networks and to applications. So we wanted to go over some real basic broken windows. The first one here we have is test pages. So there's a few different things you may see for a test page, right? You may see an e-interface with no backend, so you have an HTML form that when you try to submit it, it doesn't actually do anything. You may have some debug pages or things that were used to kind of test the functionality of the site before it went into production. If you're seeing these on a live site, it means that they probably didn't go through and carefully remove these kind of test pages before it went to production, right? If you're getting debug messages, that can tell you a little bit about what's going on in the backend system. So it gives you a little bit of insight. And you may find some non-production functionality, which may be more prone to simpler types of attacks. They may not filter as well, for instance. Things like typos can show you that it sort of implies a lack of care, right? Somebody didn't go through and carefully work on this, right? They may have just rushed it out, and when you rush things out, there may be some new stuff kind of behind the scenes. If you have a really ugly site or it's got animated GIFs, that may tell you that it wasn't professionally developed. Yeah, and it may also tell you that it's an old system, right, or just an old application. So when I see something like that, the first thing I want to look at is do a little bit of recon and try to find some older vulnerabilities, do a little research, right? Same with broken links. It shows nobody's watching, nobody's monitoring it, right? Things are breaking and nobody's going through and fixing it. And then verbose robots files. This can be a roadmap to sensitive files. When you have people that put things in there to block them from, say, a web crawler, that tells you a couple things. First of all, it points you to some really neat stuff sometimes. But secondly, it shows you that whoever developed the site and put together this kind of robots file didn't they didn't really grasp the security implications of it. They didn't understand that it's not meant to be used as a security mechanism. And if that's the case, then what else did they kind of not do right?
So here's an example of a really egregious robots.txt file. Just to be clear, we didn't actually find this on a live site. I really wish we did, because if I ever saw a directory called pictures of me in a tutu, you know I'd visit it. I would love to see that, not because I'm weird or anything. I mean, I am weird, but all right, moving on. So, but all of these things make me go, ooh, what's that? So this kind of, especially something like /admin, that implies that, because really, this is for those of you who aren't familiar with the robots standard, this is basically a list of what crawlers and applications are or aren't allowed to go visit these things. So if you're putting something like /admin in there, this is just like is an honor system. It's like, please don't visit these things. So like, this is the sort of thing that would set off alarm bells for me. Just the fact that there's a robots.txt file there, okay, whatever, and seeing that for like different product pages or something like that, or user functionality, which is linked from the normal like menus and user interface of the site, is not necessarily bad. But when you see things in there that you find new application URLs, new paths within the application in the robots.txt file that you wouldn't find through normal browsing, that's a red flag, because it's like, okay, well, why did they put that in there if no crawler is ever going to reach that? So that's interesting.
So here we have credit card numbers are 100% secure. I don't know about you guys, but if I went to a website and saw this, I'm going to think really hard before I go through and put my credit card number in. These aren't really used nowadays. So seeing this tells me that there may be some older vulnerabilities present on the system. So some more broken windows. We have HTML comments. Sometimes you'll see these and it doesn't really add up to anything. It's just quick notes from the developers. Sometimes you'll get lucky and you'll see usernames and passwords that are put in there. You also may get some insight into how the backend system is working. They may have comments that are talking about how they're going to process information, that kind of thing. If they aren't going through and removing some of that stuff before it goes into production, then it really begs the same question. How well did they harden things up before they moved into production? Spam posts. This is the same broken windows idea, which is they aren't monitoring properly. There may be bad filtering on the site. And if nobody's watching and not taking these down, then they may have already had a breach and they just don't even know it. When you see old kind of technology like classic ASP or really, really old web servers like IIS 4 or 5, that's going to tell you that they aren't maintaining, and you can probably find some older vulnerabilities as well. Some really quick research into known vulnerabilities for that web server may turn up some stuff that still works for you.
One more thing I wanted to mention about the old tech thing. It's not necessarily that nobody's updating the website, although that's frequently the case. It might be that this is just built a long time ago, and it's been sort of like they've been like just since years ago been putting patches and patches on this old piece of technology, and it's just you can only put on so many band-aids on something before it's just like, okay, let's throw this away and build something new from the ground up. So that might indicate that they're just, throwing patches after patch after patch after patch on this old thing, and there's a good chance that you're going to find something that hasn't yet been patched.
So we have a weak password policy. That shows just kind of a lack of understanding of basic best security practices. If you can also find username enumeration, then brute forcing might also be trivial. And then password hints, these are kind of a fan favorite with us because we aren't talking about security questions, right, where it's asking you a question, you give an answer. It's just a hint to what your password might be that you're putting into the system. So this inherently weakens the kind of security mechanism, right? It gives someone a hint towards the password that they may be able to turn up just with a quick social media search, right? If it's asking what your dog's name is, I could probably find that on your Facebook page. One thing that you'll also see a lot of the time is people will just put their password as their security hint. So you can just hit the hint button and it'll give you the password.
So the thing about password hints is that it's, like Chris said, an intentional weakening of the security mechanism, which is maybe a choice that you want to make for your particular application, but it's usually a choice made not in favor of security. So that's an indication that something might be vulnerable because there are intentional choices made to weaken the security of the system. So here's an example of some spam posts, and I think we actually took this off of a forum posting about erections or something like that. So this these might actually be legitimate comments, but if you were to see this on ilovepuppies.com, well, this is probably spam posts. And similar to the whole thing about, this is probably the closest analog that we have to broken windows on a building. It's somebody vandalizing your property and you haven't really done anything about it, or you don't have the resources to do anything about it. So that's interesting. And so here's an example of something with password hints. Now this is a little bit better than what we usually see. What we usually see where password hints are involved is you see some sort of login prompt where if you get the password wrong but get the username correct, it'll say, okay, well, you got the password wrong. That's okay. We all make mistakes. Here's a hint for you. And, so like I said, that's an intentional weakening of the security. This one's a little bit better because you at least need to get two pieces of information correct. Sometimes you'll have functionality which will just say, do you need a hint? Put in your username and we'll give you a hint. And frequently you can just put in random usernames and it will confirm for you by giving you a hint or not giving you a hint whether or not a username is correct. So that can be a problem in and of itself. And the next thing is overcomplications. Now this is a big one. This is when you start to actually delve into the application itself. So one thing that we see frequently that sets off alarm bells is unnecessary input. One really easy to understand example is if you're working with a shopping cart application, and when you put something in your cart, you see something in the post body like ID equals X, and product name equals Y, and price equals Z. Why should I need to provide the price to the application that's selling me a product? Like that price should be on the server. Like I shouldn't be needing to give you the price there. And so the question naturally comes up, well, what happens if I give it a different price? And this used to be a huge problem in shopping carts, and we still see it today, but sometimes you can modify some piece of information like that. Another example is when you see something like a username. Not so long ago, I was testing a piece of forum software where every post you made, you would submit a username with the post. And again, if you're logged in, you shouldn't need to provide that information. You know, your browser shouldn't need to tell the system, I'm making this post and here's my username. And it actually turned out that you could post as any user you wanted just by changing that username field. So that's the kind of thing that will throw up red flags for us. Sometimes you'll see odd program flow, some application that works in a really kind of backwards way and it achieves what it's supposed to achieve. But you know, one thing that we see sometimes is processes that don't need to be multi-staged that are multi-staged. So you know, let's say a password reset, for instance. What you could do for a password reset is have a page that says, you know, put in your username and select the security question that you want to answer, put in the answer and a new password. So if you get the username or the answer to the security question wrong, it's not going to do the password reset for you, and you don't have to do anything like reveal the username or reveal the security question. You don't have to, you don't, as an attacker, you would have to be guessing all those pieces of information simultaneously. But more frequently than that, what I'll see is something where you have a multi-stage, where first stage you put in a username, second stage you answer a security question, and then third stage you reset the password. So there's a couple different problems that can happen with that. The first problem that is always a problem there, if you put in a username and it passes you on to stage 2, you now know a valid username for the application. What I can frequently do is go to stage 1, put in a username, go to stage 2, answer the security question, go back to stage 1, put in a different username, and then go to stage 3 and set a new password. Now, what frequently happens there is that you sort of confuse the session where, you know, stage 1, you put in the correct username, and it sets, you know, some like username variable in your session. It associates you with this particular user. And then you answer the security question, and it sets some flag like user has answered security question in the session. So then when I go back to stage 1 and set a new username, I've already got the flag set that said I've answered my security question, so I can go on to stage 3 and set a new password, but I can go ahead and change the username with stage 1 before I go on to stage 3. So we have like a bypass of the security question. We've broken the authentication by skipping around in the flow. And if you don't need to do like a multi-stage process, you don't even have to deal with problems like that. So, you know, odd program flow will often tell us that something weird is going on here, that they're doing something in a weird way that probably they haven't thought about too well. I'll let you talk about that.
Session destroyed on password change. You log into an account, you go to My Profile, you go change password, change your password, and it logs you out of the application. Right? That can tell you a few different things. First of all, that's just not necessary. Right? That also may tell you that in your session cookie, they're putting your password in there, so that's why you're getting logged out, is the password's no longer valid.
So another thing is it might not be in a session cookie necessarily. You might be doing the sessions properly, but maybe you've put the password in as a session variable, and when you go to check authentication, you're checking not that the session has a valid username, but you're actually doing a lookup against the password every single time. The problem with that is that this information has to be stored somewhere, right? The sessions have to be stored somewhere. So if, let's say you've got an application on shared hosting, PHP by default will store all its session files in /temp, which, by the way, is accessible to everybody. So if you're able to access those files, you can see everything that's in someone's session. So if I manage to get access to those session stores, all of a sudden I have passwords for people. And the fact that you don't need to put passwords in the session, in session variables, you know, it's a bad idea. So you really don't want to be doing that, and so it's an indication that something again is weird. So here's an example of the sort of fields that shouldn't be in there, fields that I shouldn't, as a user, need to specify to the server. So we have an ID number, which is probably fine. There might be some direct reference problems where I can change that ID and get access to something that I'm not supposed to. But more likely, I can change the username from S McJigglebits to, I don't know, admin or something like that, and see maybe the authorization in the application is based on what I tell it. So maybe I'll get to see resources for some other username. And certainly this user can launch nukes. I want to change that from no to yes and see what happens. More frequently than user can launch nukes, I'll see something like is admin. And you can tell what probably happens when you modify that.
Some more types of broken windows, things that are going to show you what a low-level vulnerability may lead to, is things when you have direct control over some aspects of the system that you shouldn't. So for instance, just like in the last example, ID numbers, right? That really should be stored in your kind of session variable. That shouldn't be in a cookie. That shouldn't be something that a user can control. But what happens if you change it? Are they sequential? Right? What happens if I subtract one? And then what's the first ID? Let's say that they are sequential. Right? What is ID number 1? Is that the admin? Or maybe 0? Same thing with the usernames. You may also be able to use this to enumerate usernames. So if you guess one and it breaks your session or does something else weird, maybe it's a bad username. So it really is change it and see what happens. Right? File names and paths. Kind of the most simple use for this is a path traversal. You can use that to enumerate the file system, and it might give you some kind of insight into what kind of operating system they're running or what's going on the back end. And then HTML and SQL, right? You really don't want to see that going out in a request to the server. You may, of course, get HTML injection or possibly some cross-site scripting if it's just pure HTML that's going out. The better one is SQL, right? We've seen this a couple times, and it's almost a direct pipeline straight to the backend database. Right? Normally, it's not filtered too well, and this should also make you wonder, what else are they trusting me with? What else can I send to this server that it's going to just be fine with? So here we have a quick SQL injection kind of payload. So we have a link to a login page, and then a parameter with some SQL code going out in it. They probably aren't looking too closely at this, right? First of all, this is going to tell you that they're not really following best practices, right? I really shouldn't be sending this out in the first place, but they also probably aren't checking it, so you might just get full kind of access to the database with one link.
Sometimes you'll see something like this, except it'll be obscured in some way. It'll be encoded as ASCII hex, or it'll be encoded with base 64. So that's interesting stuff. We'll talk about that a little bit later, but I know that whenever I see a base 64 string in an application, the first thing that I do is decode it. Sometimes you'll see like odd filtering. Some sites will have like a pseudo WAF in place. They'll have some sort of wrapper around every single script that they run, which just checks all the input parameters for bad things and tries to either remove them or reject the input. And based on what things are being filtered in that sort of scenario, and the fact that they've tried to roll their own WAF is a big red flag anyway. But you know, if you have an application that's doing weird things with your inputs, you might try adding some fake parameter at the end of a URL and seeing, like, if you put the word script in there, does that get taken out? Does that get filtered from the resulting page? And that might indicate that you have some sort of overarching protection, where some developer was like, I really don't want to encode all my output because that's annoying, so I'm just going to put this thing that looks for any instance of the word script and takes it out, because of course we can't do any sort of cross-site scripting without the word script. So, sure.
One thing that I've seen, and I always love to see it, is if you see they're filtering out the word alert. A lot of vulnerability scanners and pen testers will use an alert box as a proof of concept for cross-site scripting. So that goes back to the developer, and they don't really know what to do with it. They don't know how to properly filter for cross-site scripting, but they see that you have this one word that they can filter. So they filter out the word alert, and that stops your proof of concept from working, but it doesn't stop you from getting a cross-site scripting payload to go through.
Yeah, I mean, actually, if you have an application that just takes the word alert out of any input that you give it, that's going to stop a lot of vulnerability scanners from identifying cross-site scripting. So you prevented the vulnerability scanner from seeing that you have a problem, and maybe this is because you don't actually want to fix it, you just want to stop the guy who runs the vulnerability scanner from complaining to you, or you really don't understand what's going on and you just want the vulnerability scan result to go away. So this, either way, it's an indication that you really want to dig deeper into this application. Probably if you have some sort of overarching protection like that, it's not working properly. Sometimes you'll see user-defined error messages. This is interesting because, let's say, one place where I see this a lot is on a login prompt. So if I get an incorrect login, it'll come back and I'll see in the URL error equals that username or password. And if I change that to never gonna give you up, and that shows up in big red letters on the login page, I know I can send a message from the website to a user through the URL. So if I can launch some sort of phishing attack against users and provide my own error, I can say something like, sorry, this computer has been locked out of this system. Please call 1-800-ATTACKER to reach the help desk and get your password reset. Something like that. Now, there might also be cross-site scripting issues in it, but having a user-defined error message, just somebody wasn't really thinking like, what if I was a jerk? What would a jerk try to do with this website and this functionality? Directory indexing. I love seeing directory indexes because this tells me that basic hardening measures on the web server aren't being followed, because that's one of the first things you do. And frequently, if you have like a modern web server, that's going to be disabled by default across the board. So it tells me either you've actually enabled this for whatever reason, or you've got an old version of the web server that doesn't disable directory indexes. Either way, I know I'm going to find something. Anytime I'm in a test and I find a directory index, I know I'm going to find something. So I always want to go after a target that I see some sort of indexing. Username enumeration. Here's one that's a little bit different from what we've been talking about. So we mentioned username enumeration a bunch of times. Simplest example, the most common place where we find it is where you go to log into something and you say, log in with good user, bad pass, and it says, sorry, you've got a bad password. Try again. So I log in with bad user, bad pass, and it says, that username isn't in our system. So we've confirmed a username in the system. Now, we see this a lot. In the vast majority of applications that we test, this is something that we find. And it's not a huge deal. It's one of the it's about the lowest. We give it about the lowest severity in the reports that we can, because really by itself it's not a big deal. In combination with other things, it can be a big deal, but by itself it's not very bad. And we find it everywhere. So if you find a system that does not have this flaw, that's actually an indication that this might not be vulnerable, that this is something that you don't want to test, that this has already been given a little bit of gentle security caressing, and you just want to move on to something else and try to find something that's a little bit less protected. So here's an example of directory indexing. We pulled this off of some random web server, but this is a wonderful thing to see for me because I know I'm going to find something. The other thing about directory indexes is it might reveal to me some sort of application path, some sort of directory that I didn't know about previously, that's not directly linked from the website itself.
Okay, so this first guy here, the pre-filled password field, we're talking about if you see something like this, right? You go to change your password and it's asking you for your current password, but it already has something filled in. Now here it's masked, and that's not really useful, except the second that you go look at the HTML source, it's going to be right in there, right? Now, they can kind of assume, okay, well, this isn't too big of a deal because they're already logged into the application, so who cares if they see their password? But that really doesn't take into account what if they're on a public computer and forgot to log out. What if someone's kind of looking over their shoulder, or there's a man-in-the-middle kind of type of attack going on? And what if there's some other vulnerability somewhere? What if they've already been owned and someone got access to your user? Well, now they have access to your password as well. This can also show that they aren't hashing passwords, right? So they shouldn't be able to give me my password back. And it's a self-defeating security kind of mechanism, right? It would actually be less vulnerable to just not ask for the current password at all and say, okay, we'll put in your new password. Verbose errors, we kind of went over this a little bit already, but it gives you some insight into the back end. It may tell you what kind of operating system they're running or what type of web server they're on. And it shows that they just didn't go through and harden properly, right? This is something that should have been disabled before it went into production. And that kind of begs the question, what else did they forget to turn off? And then when you have a password sent to your email, clear text, let's say you go and use a forgot password form, and you go check your email and it just sends you your current password. That tells you, just like with the pre-filled password, that they aren't hashing your password. They really shouldn't be able to give you your password back. But it's really better to send a link that'll bring them to a page to change their password, or to give them a temporary password. Because that, when you do it this way, it kind of assumes that their email is very secure and will always be secure. Right? With a temp password, it's going to be changed quickly. So if someone gets into my email 2 months from now, they're going to be able to go through and, oh, well, here's the password. When it's just sitting in there, you're probably not going to change it when you log back in.
Yeah, sending a password, clear text in an email, you're assuming a couple things. You're making assumptions that somebody else is going to take care of the security. The user is going to delete this email when they're done with it. The user has properly protected their email, so nobody else is able to get into that. The user has properly protected their network, so nobody's going to be able to eavesdrop or do a man in the middle. You've properly protected your network, so nobody's eavesdropping on your side to see when you email out clear text passwords. So there's a lot of assumptions being made here, so you're relying on a lot of things for this, this security mechanism to really work. So even if you're sending out a new temporary password, that can be a problem. So there are certain things that we'll find that just indicate that somebody hasn't been making applications for very long. Either that, or they're just unfamiliar with security concepts. So has anybody heard about the recent IEE breach? Okay, so I see a couple hands. Based on their description, and they haven't given details on what actually happened beyond like some vague details, but it sounds like that they were passing credentials off to a back-end system to go through the authentication process. So they don't actually do authentication on that system exactly, but some other system in the back end. And it sounded like what they were doing was putting the credentials in the URL. Now the problem with that is that web server logs will cache all of that. So it seems like my guess, based on the details that they gave about the breach, is that they were passing these credentials in the URL to some back-end system and assumed, well, nobody's ever going to see that because nobody's going to be in our back-end network, except the web server logs were available on their public FTP server. So somebody was able to grab the logs, and that's why it accounted for only a certain percentage of the users that were actually in their system, because maybe this sort of thing was only in place for a short period of time, or they only had the most recent set of logs. Maybe they're doing sort of like log rotation and switching out the logs at some point. So it was only X number of users who would log in past a certain point who were affected by that breach. So that's a problem, because you're not understanding the difference between get and post. You're not understanding that if you put something in a URL, it will get logged by browser history, maybe, by web server logs, by proxy logs, by all sorts of places. So it's an indication that you don't really understand the difference between get and post, that you haven't been doing this for very long. I really, really love when somebody says base64 encryption, because base64 is not encryption. It's very, very trivial to decode base64. There's plenty of resources that will allow you to do that. If you have a lot of time on your hands, you can do it by hand, although I don't recommend it. It's not encryption, and a lot of people think that base64 is an encryption algorithm. It's not. So one of the things I was saying earlier is I like to just decode any base64 string that I see. One recent test that I did, there was a cookie that had just a base64 string in it. It said something like, MLK authentication or authorization or something like that. And if you decoded it, it was just the username :password in a cookie base64. So I'm guessing that these people didn't understand what base64 was. If I see something like that where you're just obscuring things with base64 that really don't need to be put through base64, either you're just putting some band-aid on something and hoping no one will ever pull away the covers, or you just don't understand what base64 is, and so I'm going to want to look into that system. Claims of security. Has anyone ever, did you guys hear about that product where, somebody was saying, hey, this is completely, 100% hacker-proof, and it didn't get owned like a day later? Because I don't think I've ever heard that story. I'm pretty sure the way that usually goes is they claim it's 100% hacker-proof, and then the next day somebody releases some like remote code execution bug for it, like the very next day. So, but this is a fundamental lack of understanding about security and what it is. So if you're saying that something is 100% secure, you don't understand security, because I just don't think there's anything that's 100% secure. It's a matter of degrees. It's like, how much effort have you put into this thing? And if you're a dedicated enough attacker, you're going to find a way. It might be costly to you, it might take time, but you're going to find a way in. So to claim that something is completely secure, unbreakable, whatever, is just a misunderstanding. And so if I see something like, you guys see the McAfee HackerSafe logo on websites sometime? I want to go after that, So a lot of people will be like, oh, well, we're HackerSafe. We don't need to worry about application security. We're good. We're HackerSafe. So, and that's a good step. Vulnerability scans are good, but they're not the end-all, be-all. Case-insensitive passwords. So this indicates one of two things about how you're doing your authentication. When you hash something in an uppercase form or a lowercase form, it's going to be a different hash. So if I can log in with the same password with modified case, it either means that before you do the hashing, you've intentionally, lowercased or, made the case not matter, or you're doing some sort of case-insensitive check against a plain text password, or just a password that you've freshly decrypted from the database. So it either suggests that you're not hashing the password, or you're intentionally weakening the security. Like we said earlier, that might be a choice that you want to make for user friendliness, but you've chosen something else over security. And so that's probably going to be a system that I'm going to want to go after. And then, lack of transport security. If you're logging in without SSL or some other encryption mechanism, that's going to expose the password. And again, that's assumptions that, everything in the middle is safe, that, that somebody else has taken care of this security issue. And I shouldn't have to worry about it because it's not my problem. So, yeah, I still don't believe it.
Okay, so how do you develop your own Spidey-Sense, right? For us, it's really just a matter of looking for patterns. The way that we first came up with this is every time we'd find, certain serious vulnerabilities during a pen test, would notice the same kind of low-level vulnerabilities were also present. So they can kind of work as a roadmap for you. If you take notes, right, it's kind of the same thing. If you see these low-level vulnerabilities and then find the same high-level vulnerabilities repeatedly, write it down, take notes, look at old reports, right, but just trying to spot those patterns. And then the last one's just practice, practice, practice. Get as much experience as possible, and just keep your eyes open.
Yeah, I had a friend who asked me a while back, and it was something of an inspiration for this talk. He said, when you're on a pen test, how do you pick out targets? Like, how do you think, like, okay, well, maybe this is vulnerable? And he was asking me not because he wanted some, list like this of like, here's this and here's what it means and here's why I go after it. It was more like, can you even identify? There was a great quote that I heard not so long ago that said there are 4 levels of knowledge. There's the things that we know, that we don't know that we don't know. Then there's knowledge where you know that you don't know it, and then you know that you know it, and then you don't know that you know it. And that's a little bit confusing because I did anybody count how many times I said no, because there's a lot. But anyway, so at some point it becomes just you stop thinking about it, and you know that hey, there's a typo on this. that's bad. I'm going to want to go after that. But you don't even think about it. You just see it, and something goes off in your head, and you want to attack this thing all of a sudden. You just pick. So it's helpful to really analyze that and to get to the bottom of why this thing means it's probably vulnerable. So it's good to sort of consciously make that connection and stay that sort of that like third level, because then you can say, okay, well, base64 being used as encryption, that means they don't know what they're doing. So, if I see something else that indicates they don't know what the fuck they're doing, I'm going to want to go after that. Even though it's not something I've necessarily seen before, even though I haven't made that connection through experience that, this means that, I can sort of pull on inferences from earlier experience and say, this is probably vulnerable, even though I've never seen somebody do this before. That's weird. Or that probably means this. So I would recommend getting bit by a radioactive pen tester, but I can't because Trustwave Legal shot that down. So if you do, well, don't tell me about it. So now I'd like to open it up to questions. Okay, it looks like everybody's all set. So, thank you.